As you may expect from the title, most of my practice deals primarily with wearable technology. Usually I approach it from the research angle, so less gadgets. And my main interests lie in exploring worn light and lighting, sensing our immediate surroundings, and expanding our means of expression. On the screen right now, you can see a couple of the projects that I finished within the last 2 years. The two on the right are projects that I've done with the Social Body Lab, and the project that I'm talking about right now is called Icky Poo. The primary goal of Icky Poo is to create a co-located network between Buenos Aires, Argentina, and Cusco, Peru, facilitating a group of movement artists to perform together in a shared environment. This is not a literal translation of the body through space. Rather, it relies on approximation, symbolic representations, and the lens of a 16th century text compiling pre-Columbian Andean religious rites. What does Icky Poo mean? A Icky Poo, to put it simply, is a data storage device. And to put it very simply, this is a Icky Poo, and I would say that it is an early example of wearable technology, and it consists of a single cord with attached strands. Each strand contains carefully placed knots, and it is capable of representing time, numbers, and events. From recording transactions, debt, to specific or important historical moments in either, usually in the context of a small social structure. Most importantly for me, I guess, is that it is worn on the body, and Icky Poo is an individual that can understand this code and encode it and proceed to decode it to pass it on and continue the tradition. So the scope of the project is quite, you are not supposed to read that. It's very ambitious. It will happen, the actual event will happen in November of 2016. The exact date is still being set. It will take place in both Buenos Aires and Cusco, and it encompasses 15 one-hour performances over 1 week. This will include things like projection mapping, dynamic audio generation, live performance, both acoustical instruments and as well as movement artists. It'll even include gameplay elements to some extent. Again, tying things back into the 16th century text. The wearables component is what I'm working on, as well as a part of the dynamic audio generation. I'll warn you that I'm not a musician, and I actually know very little about audio before I started this project. And this is why I've carefully named the talk, or at least a part of it, as sound and not necessarily music. So I'm going to do, I think, a quick demo, and provided that everything works, let me try it out. So you hear some things. So the primary device in this, in my wearable experimentation, has been a little thing called a light blue beam. And the point of it is a very small Arduino device, but it's directly attached to a Bluetooth low energy chip. And so it's very simple to interface with it and so on. And you can use multiples very easily, which is very important in this project, as there will be about 4 per person, and there are about 10 people. So it needs to be scalable. And so this could be, is this the fire? Let me find out. Well, first of all, let me show my awesome debug system here. This helps me figure out whether they have disconnected or not. So something you hear is, so this is a threshold-based interaction. Let me increase the audio on this a little bit. And the idea is that for this particular device, it has a kind of instrument within it. And the idea is that this instrument is triggered by motion directly. There are others here, and you see it went silent. One of these represents wind and another fire. This is the wind. And some rain. And this is the fire, provided that everything is working. So you can still hear the rain. Anyway, so this is the current status of the project. The wearables still have a long way to go. And I will continue, hopefully, onward. So this is Asto, and we have already done some workshops in Buenos Aires and Peru, in Cusco. And he's actually holding one of these beans right now. And to kind of show the range of placement possibilities and so on, this is another bean on Lorena's foot. And she quite enjoyed putting it here. We've experimented where one might go and what kind of movement individual artists may perform. And a whole part of the process has actually been cataloging various movements that they do, kind of letting them express themselves any way they want, and then making a small subset of a language based on various movements. Continuing. So this is kind of my part of the project. I'm not going to go into code, just partially because I have very limited time. But the whole point is that I'm using Overtone to actually generate the sound, which is perhaps unsurprising, and as well as ClojureScript. And you may wonder why I would want ClojureScript. Well, I'm an artist. I'm not necessarily a programmer. And so something that really helps me with Clojure is actually having the ability to interact with multiple different languages. And ClojureScript has helped me immensely with interacting with Node.js. I can use very similar concepts that I use in my, for example, Overtone code and other code, open sound control code, in that area. But I can also tap onto libraries that I don't directly have access in, even on a JVM. For example, Bluetooth Low Energy is fairly recent, and although there are options for it, they're quite beyond my scope at the moment. And so Bluetooth Low Energy actually got picked up a lot by the IoT community, and a lot of it, from Intel to others, are kind of using Node as this maker experimentation platform. And so I end up having the benefit of access to this, which has been really wonderful. And so you see that like the device server, which connects to all of the BLE devices, is written entirely in JavaScript, ClojureScript. It transmits raw data over open sound control, and then a subset of the code that just generates triggered commands. And the reason for this is the commands are what actually activate the sound, and they need to be transferred over to between the locations. But they don't just make the sound, they will also create the aforementioned projection mapping and various other interactions. So from then on, it generates audio, but it can also go to all of these other areas, depending, as well as go across the Andes into the other city. And it's nothing sophisticated, but so part of the reason why I began learning Clojure a year and a half ago is after watching some of the talks from conferences like this one, I realized that it is going to be a lot more helpful for me to learn this language as opposed to something like Java directly. So I wanted to list some of the things that really impacted me as I've worked with it. And the best part, as I mentioned, has been sharing the concepts. One of the best libraries that has really simplified my workflow, and I'm using it very simply, but it's Core Async. And all I'm doing with it is basic channel subscriptions. And the thing about that is that I'm not really using the full power out of it. I'm not really optimizing it 100%. But what allows me to do as a I guess, programmer is to structure my code in a way that I can kind of keep it all in my head. I can be very linear as I want with it, and I can separate a lot of my program out into different parts that then reliably talk to each other. And so just learning a little bit about it and kind of diving into a lot of the wonderful tutorials. In fact, the tutorial that helped me the most was Bruce, and I'm sorry, I'm going to mess up the last name, but Hauman. A UI tutorial about how to, this was I think from the summer of 2013 even, about how to structure a user interface interactions. And so I took that idea and I went all the way to something like these wearable devices where they generate a lot of data and then I generate a lot of events from that. And so transferring that from one stage to the next has been really helpful. Other amazing thing is diverse interests in the community. And this has really helped because the sound is not something that is hugely done on the Node side. Like there are options, there are things, but there's nothing in the same realm as Overtone, for example. And the biggest benefit with Overtone for me is the fact that it was created with a very specific mindset in mind, primarily that of live coding. And live coding is a way of creating. And I wanted to kind of have that as a possibility within the project even. But also it deals not directly with various nodes and chords and so on that I have very limited understanding with. But it can kind of create synths, and I can pull in sound files and I can mix them and really play with it without having a very extreme understanding of music. And eventually I hope to have that understanding, but at this point, while I'm prototyping, it has been immensely useful. And again, this comes to the rapid prototyping possibilities, the REPL, and so on. That has been a very important part to me as well. Just being able to, even ClojureScript REPLs have become so robust in the last few months. Being able to prototype on Node, deal with my data, transform the data structures from these devices, and then massage it to make it useful to me. Last thing I want to talk about is kind of back to the project, and that is future work. And so we have another set of workshops in October, and the workshops, the two GIFs that I showed are available as video if anyone is interested. And the goal for these workshops is to actually have these be wearable. And so part of my project right now is actually exploring sensor possibilities. And the direction that I'm taking is sensors that are actually more communal, as in it's not just sensing the body's movement, but it's also allowing other dancers and performers to interact with each other. For example, touching certain parts of the body will trigger certain events and so forth. And these will eventually be integrated into various costuming options and etc. And provided, I think that is all that I have for this. Yeah, and I have a minute or two for questions, and I was wondering anyone has any?
What are you using to get data out of the devices?
Noble. It is a Node.js library for Bluetooth, low energy specifically. No BLE, I think, was the sentiment behind its name, even though it doesn't.
So the little wearable units then, you said those are human-based, are they communicating via Fermata or?
No, so the way BLE works is that there are options with Fermata, but they're actually observable, which is the difference between Bluetooth, where you open a direct pipe and things just go through. The reason why these are low energy is that you can kind of just look at them, and I'm being very simplistic, but you can kind of just look at them, and that is what, and you can see various parameters that you store. So really all I'm doing on these devices is I'm storing Scratch characteristics, storing data in Scratch characteristics based on the sensor output. And then I'm observing that with ClojureScript. And that way I can control the rate of the data on my end here instead of constantly going back to the smaller device. Yes?
What's the latency between Cusco and Buenos Aires, and does it matter?
We have not tested that yet. One of the things that I kind of wanted to mention is the nice thing about this project is you're dealing in human time, like very human time. So audio, which is fast to create, and you need speed to create and process it, but actual sensing it and so on is, we have a lot of wiggle room with latency, especially like from these devices. One of the primary feedback elements we got was that people preferred to have a reaction after they've completed the gesture. So there's some kind of moment of pause, which is not directly related to latency, but we got to that point because of some latency issues. I think I'm out of time. Okay. Thanks.